stage area. So please welcome the lead robotics engineer R&D at Interactive Scape, Dr. Előd Páll.
Thank you. Welcome, everybody. And let's jump into the talk. We are going to talk about LEROSH advancing toward Craft 4.0 and beyond. Who are LEROSH? LEROSH, we are a research project, Lernende Roboter Schleittechnik für das Handwerk. And in this project, we are six craft businesses together working with 2 research industry partners, 1 digital interaction expert, and 1 crafting tool expert, all from Germany. And the goal is to improve robotics and integrate into the craft sector. What is craft sector? One of the examples that we are looking at here is our partner at Werk 5 processing different surfaces with tools. They use power tools, and the goal is to sand the surface homogeneously. This is all done manually, and what we would like to do in Craft 4.0, that we have a robotic system, like here in this simulation, where the robot, intuitively, you can design, the craft person can design the task, such as drawing onto the surface, and then the robot follows the desired motion and sands the surface. So this is the goal, and we want to go even beyond. You might ask, why do we want to integrate robots into crafting? Well, already the ministry observed that there is an issue, and we need to help the craft people. They are running low on trainees. Fewer and fewer people would like to join and learn the craft. In the last 40 years, the number of trainees halved. So there is fewer people. They have less help to support the craft people. And why? Because the job sometimes is dull, dangerous, dirty, and difficult. If you need to sand metal or different materials, then the particles can be dangerous for your health. All day long sanding with a power sander actually is very bad for your joints. They need to take breaks. So some of these tasks that are dirty, dull, and dangerous and difficult, we would like that we give to robots. And that would help craft people to really enjoy the crafting process, to do creative work, and create new objects every day. So where are we now? At the moment, robots' costs are not in the sky, but still not yet fully accessible for craft people. And the robot capabilities are also not fully available. So robots are not fully capable to support them. What we want to develop new technologies for craft people to accelerate the usefulness and the capabilities of robots and integrate these into the daily processes. We face quite a few challenges, and the 2 big challenges I will show you here, this is one of our partner showing how to prepare a cello plate. And as you can see, this is a custom-built cello plate. It's manual work, not even just sanding, sometimes even carving. And one of the problems is that here we have a low-volume, high-mixture production, meaning 1 batch size. Each cello plate is different. So traditional automation technologies are not applicable for crafting. And 2, it's a contact-rich interaction. You need to interact with the object and change the object while you are in contact. This is a challenge for robotics. You need special tools, special robot equipment, and what is right now the trend, you use AI and data to make your system scalable. We don't have the data. We don't have like large language models online, all the text and all the images from which we could learn. So we need to generate data, and we need to make a system agile enough to work for craft people. So here is an illustration of the current trend. We have Industry 4.0, that is great, but it's difficult to apply to our problem. And our idea is to integrate human into the loop. And I will explain you what we mean by that. Basically, there is software on the top side, and on the bottom side, you have hardware. These are working together to solve problems. Now, we take the human, the craft expert, integrate into this loop, and can support the system with their skill. And here is an example where we already developed the system that I showed you, that this is Craft 4.0 that we imagine. We have a UI designed where one stroke of line, and you can start sending. You don't need robotic expertise. You don't need an engineer. You just need to be a craft person to know how and where to send the object. You can intuitively control the robot. So one of the key aspects to revolutionize the crafting field is to make interaction with the robot intuitive. Behind the scene, it's a complicated system. And to make the system useful, we need to make it modular. It's not just one cobot that specifically we would like to use. Any cobot should be available based on price and accuracy requirements. So it's a modular system. You need cobots. You need special tools. You need to be able to change these tools between different tasks. And you need software to be modular. Software that is fitting for different tasks and for different hardware equipment. Here in our application, we use a web app through which we can control the robot. And we use ROS to create a modular software ecosystem. And this is connected with a cobot, in our case, with a KUKA robot. But our partners in the consortium, they use a UR, for example. And the system needs to be also flexible. This is what we learned from craft people. This is my colleague from Werk 5. Hannes comes to our lab and frequently gives us feedback. So he's a craft expert. He tries our system that I showed you. That is one stroke and the click to send. He tried the system, and we interact with the craft people daily and learn that they need a flexible system. They don't want just an automation. They don't want that you click and everything is done. They want sometimes to manually control the robot. They want to teach new skills to the robot, to process new objects. They want to interact with the robot. So you need a flexible system that is not fully automated, but it allows different ways of usage. We also learn other interesting things from craft experts. And one of them is tooling. They use different tools. On one side, you see that for different tasks, different tools they are preferred by craft experts. We conducted a study and seen that it's not one tool fitting every job, like usual. So what we did, we integrated multiple different tools, even modified some of these tools to fit to different problems. So tooling the robots is very important for us. But for that, we need to build special tools that fit the task. Oh. Another interesting thing that we learned from craft experts, here again you see the same motion or the same sanding process by 3 different craft people. And they use the same tool, but they have different motions while they use it. And we see that these motions are key for sanding. To blend in the scratch marks that this rotary sander makes, they apply zigzag motions or swirl motions. And these motions we can describe mathematically. How to describe them? Well, we conducted another study where we sensorized the tools that they use, for example, a sanding brick that has a force torque sensor that is tracked the position, and we can record data directly from craft people. So this is the way we imagine to learn their skills and transfer that to robots. What we learned is that they use circular motions, which can be easily described with a specific mathematical model. It's a dynamic motion primitive, and a special branch of that we use. We implement this and integrate into our system. This way, we can teach skills to the robot on the fly with just a click. And here you can see our UI, where we teach a new skill to the robot. This is shown on the left side. Apply it on the blue line, and now the robot follows the purple line and not the blue line, blending in a repetitive motion. At our hall 2, stand B16, you can also try it. Visit us, and we have this UI there prepared. You take a pen, you draw on the surface, click, and the robot will start sanding. You may wonder that, oh, did we reach Craft 4.0 and how we achieve it? Well, we have not yet reached that. This is a research project. We propose only some technologies that will advance and help craft people to use robots. One of those is we develop technologies to interact with robots, not just with no code, but with intuitive user interfaces. This is one of the prerequisites. When you want to integrate craft experts with robotics, you cannot assume that they learn robotics and they will understand how to program robots. So you need to have a very intuitive, not just no code, but intuitive user interface. Second, you need a modular system architecture, which means you can replace what cobot you use. You can replace any cobot. You can use whichever you want. But for that, you need software that can integrate these cobots. Secondly, you need a flexible system. It's not only automation that we want. Craft people need to interact with the object and with the robot at the same time. And for that, we need a flexible system. Sometimes they want to fully automate their process. Let's allow them. For that, we develop technologies. For example, our partner DLR developed a motion planner that can segment the object and create a motion plan on the whole surface. And I think the most important for us is to integrate expertise from the craft people. If we want to apply robotics in any other skilled trades, then we need to learn their skills and transfer those skills to the robot. As I showed you, one of the examples is learn what tool they use and how they use those tools. We need to observe the usage of the tool. We need to sensorize those tools and learn the motion and force patterns, how these are applied on specific objects so that the robot can replicate those skills. But we need also technology from industry. And this is, for us, very important. One of those is we need standardized and secure robot operating system. ROS 2 offers some standardization and some security. It's going in the good direction, but it's far from being as efficient as computer science tools, for example, servers, web servers, where security and standardization is reaching its peak. We need similar software solutions for robots. And secondly, we need better cobots. We need more cobots and better cobots. How can they be better? Well, they need to be enabled to work in contact with objects. It's not just a pick and place task. It is more. You need to reach into contact, stay into contact, and move in contact stably. Apply the desired forces. And we need to be able, developers, to tell the robot how much force to apply. And for this, producers need to enable us to have correct APIs and use these efficiently. Moreover, we want also collaborative robots to be placed on mobile bases. The workspace of a robot depends on its kinematics, and sometimes objects in small manufacturing are small, sometimes large. If you want to produce and send large objects, these either needs to be moved or the robot needs a mobile base. And this should be all integrated together and so offered as a solution. Thank you for your attention. So if you would like to try our solution and demonstration, visit us at Hall 2, Stand B, 16. Yes, 16. And you can check out our webpage, LEROSH.de. You can connect us at LinkedIn. And if you have any questions, I'm here, open.
Thank you very much, Dr. Előd, Páll.